Have you ever wondered why we dream? What purpose do these fantastical narratives serve? Welcome to the realm of the subconscious, where reality bends and the laws of physics hold no sway. Dreams, a nightly phenomenon experienced by every living creature, are a captivating enigma, an amalgamation of memories, thoughts and emotions that weave intricate stories in our sleep. Yet their purpose and origin remain shrouded in mystery. Is it merely the brain tidying up its thoughts? Or perhaps a rehearsal for possible future scenarios? Maybe it's a window into our deepest desires and fears, or a random firing of neurons with no purpose at all. The questions are endless, and the answers elusive. But fear not, for we are embarking on a journey into the depths of the human mind, unpicking the threads of this intriguing puzzle, one piece at a time. Let's dive deeper into the science behind this fascinating phenomenon. Dreams might seem like a mystical experience, but there's a lot of science behind them. To understand the biology of dreams, we first need to comprehend the sleep cycle. Our sleep isn't a single unbroken phase. Instead, it's a sequence of stages that we cycle through multiple times each night. The sleep cycle is divided into 5 stages. The first 4 are the non-rapid eye movement NREM stages, and the 5th is the rapid eye movement REM stage. Each of these stages is associated with different brainwave patterns and bodily functions. Now, here's where dreams come in. Most of our vivid narrative dreams occur during the REM stage of sleep. During REM, our brain is almost as active as when we're awake, and several physiological changes occur. Our heart rate and breathing quicken, and our eyes dart around rapidly behind our closed eyelids, hence the name rapid eye movement. Interestingly, despite all this brain activity, our bodies become essentially paralyzed during REM sleep, a phenomenon known as rematonia. This paralysis prevents us from acting out our dreams and potentially hurting ourselves. But how do these biological processes contribute to dream formation? Well, during REM sleep, our brain is busy processing and consolidating memories from the day. Some theories suggest that dreams are a byproduct of this memory processing. Our mind might be weaving together fragments of memories, thoughts and feelings into the narratives we experience as dreams. Another contributing factor could be the activation synthesis hypothesis. This theory proposes that dreams result from our brain's attempt to make sense of random neural firing during REM sleep. The brain takes these random signals and synthesizes them into a coherent story, essentially creating our dreams. So, dreams are not just figments of our imagination, but a complex interplay of biological processes. They represent an intricate blend of memory consolidation, emotional processing, and the brain's attempt to make sense of random neural activity, all happening while we're fast asleep. Fascinating, isn't it? Scientists have proposed many theories about why we dream. Theories that have intrigued, puzzled, and enlightened us for centuries, each presenting a unique perspective on this fascinating phenomenon. Let's start with the psychoanalytic theory, the brainchild of Sigmund Freud. Freud, the father of psychoanalysis, believed dreams were a window into our unconscious mind. He proposed that dreams are a form of wish fulfillment, where our deepest desires and anxieties, too dangerous for our conscious mind, find expression. Freud's theory, while controversial, has had a profound influence on our understanding of dreams and the human mind. Next, we have the cognitive theory of dreams. This theory proposes that dreaming is simply a part of the brain's cognitive processes. According to this theory, dreams help us sort through the vast amount of information we encounter every day. They are our brain's way of organizing and making sense of this data, like a nocturnal filing clerk. Then there's the biological theory, which views dreams as a byproduct of our brain's physiological processes. This theory suggests that during the rapid eye movement or REM stage of sleep, our brain activity increases, leading to the creation of images, sounds, and other sensory experiences we know as dreams. Essentially, dreams are a side effect of our brain's nightly housekeeping routine. Lastly, there's the threat simulation theory, which suggests that dreams serve as a kind of rehearsal for real-life threats. In other words, our dreams are like a training ground, preparing us for potential dangers we might encounter when we're awake. Each of these theories offers a unique perspective on the purpose and function of dreams. They represent our ceaseless quest to understand the enigmatic world of dreams, a journey that continues to captivate scientists and dreamers alike. So, what could be the purpose of dreams? A question that has intrigued humanity for centuries. Let's delve into some scientific theories that might offer us some insights. One theory suggests that dreams serve as a form of nocturnal therapy, helping us to process our emotions. Have you ever noticed how the intensity of your dreams can mirror your emotional state? This is no coincidence. According to a study conducted by the Sleep and Neuroimaging Lab at the University of California, Berkeley, when we dream, our brain processes emotional experiences, and in doing so reduces their emotional charge. This is why, after a good night's sleep, we often wake up feeling more emotionally balanced. Another theory posits that dreams play a crucial role in memory consolidation. Essentially, when we're awake, our brain is constantly bombarded with information. When we sleep, our brain sifts through this information, deciding what to keep and what to discard. In this process, dreams might act as a rehearsal of these memories, strengthening neural connections and integrating new experiences with pre-existing knowledge. But that's not all. Some theorists propose that dreams are our brain's way of problem solving. You've probably heard the phrase, "sleep on it," when faced with a complex issue. Well, there's a reason for that. Dr. Deirdre Barrett, a psychologist at Harvard Medical School, suggests that our dreaming brain can make connections more quickly and broadly than our waking brain, possibly leading to creative problem solving. Despite these fascinating theories, it's important to remember that the science of dreams is still a relatively uncharted territory. While these theories provide potential explanations, there's no one-size-fits-all answer to why we dream. Some dreams may have clear purposes, while others might simply be the random firing of neurons in our brain. While we may not have a definitive answer, it's clear that dreams play a significant role in our emotional and cognitive processes. As we continue to unravel the mysteries of our mind, perhaps one day we'll fully understand the enigmatic world of dreams. Until then, sweet dreams. There are many myths and misconceptions about dreams. Let's debunk some of them. One common myth is the belief that dreams predict the future. This notion likely stems from ancient civilizations who saw dreams as divine messages. However, there's no scientific evidence to back up this claim. Dreams are a product of our minds, a combination of thoughts, memories, and emotions. While they might sometimes seem to predict events, it's more likely that we're noticing connections that aren't really there, a phenomenon known as confirmation bias. Another widespread misconception is that not everyone dreams. This is simply not the case. Every single person dreams, although not everyone remembers their dreams. During a typical night's sleep, we cycle through several stages, one of them being rapid eye movement or REM sleep, which is when most dreaming occurs. If you wake up during REM sleep, you're more likely to remember your dreams. So if you don't remember dreaming, it doesn't mean you're not dreaming. It just means you're not recalling them. Then there's the myth that dreams only occur in a split second. In reality, dreams can last anywhere from a few minutes to half an hour. The length of a dream can vary depending on the sleep stage and how long you've been asleep. The longer you sleep, the longer your dreams can be. And finally, some believe that if you die in your dream, you die in real life. This is, of course, not true. Dream death can be alarming, but it's not fatal. Often it's linked to change or transformation in your waking life. Dreams are symbolic, not literal. These are just a few of the many misconceptions surrounding dreams. By debunking these myths, we can gain a better understanding of this fascinating phenomenon that occurs every time we close our eyes to sleep. It's important to separate fact from fiction when it comes to understanding dreams. Despite all the research and theories, the mystery of why we dream remains largely unsolved. We've journeyed through the enigma of dreams, examined the science behind them, pondered numerous theories, and debunked various myths. Yet we find ourselves standing at the edge of an expansive ocean, the depths of which are teeming with unanswered questions about dreams. The purpose of dreams continues to evade definitive explanation. Is it a playground for our subconscious, a theatre of the mind where repressed desires and fears take the stage? Or perhaps a biological function, a nightly brain scan ensuring everything's in order? Researchers and scientists worldwide continue to delve into this captivating enigma. Every day they're exploring new theories, conducting experiments, and making groundbreaking discoveries that could potentially revolutionize our understanding of dreams. While we may not fully understand the purpose of dreams, one thing is certain: they offer a fascinating glimpse into the depths of our minds.